Hi, my name is Edward Ross. I run the Galileo and Edison businesses.
And my name is Jim Chase. I'm the platform maker for Edison and Galileo.
So we're here to talk about Intel Edison. We launched this about 3 weeks ago. So I wanted to give you guys an introduction to the platform and show some examples of some things that have been done. So right around the time that we brought Galileo to market last year, we started looking at what can we do as Intel to help enable the maker market who have decided to take products and turn these things into professional products. We are a firm believer in this 50 billion devices by 2025, and we wanted to look at what can we do to help enable not just the hardware, but hardware plus software plus services and community in order to help these guys quickly prototype and bring this stuff to market. So we announced the platform at CES, and after we got back from the Consumer Electronics Show, the initial focus was on sort of the maker and the pro maker space, but we got a lot of phone calls from our incumbent customers wanting to use Intel Edison as well. And as we asked, so the whole idea here was to help makers really quickly prototype stuff. You guys have the assets to be able to do this yourselves. Why is it that you're interested in using Intel Edison? And what we found out was that these guys felt that this would actually shorten their development life cycle 6 to 9 months as they were prototyping things. And so what we're finding now as we bring this product to market is not only is there interest in sort of the maker and the pro maker space, but also in the consumer IoT and the industrial IoT as well. Now I'm going to hand it over to Jim to walk you guys through the product.
So some of you have already seen Intel Edison, but I wanted to do a quick little rundown of it. It's basically a Wi-Fi module, but we packed a lot of power into this small little package. And not only that, we created a platform that allows you to get to the market a lot faster. So included in the platform, 1 gigabyte of RAM, 4 gigabyte of flash, a dual-core Atom device, 500 megahertz platform, dual band Wi-Fi, and Bluetooth 4.0. What we have also done is we've added a 70-pin connector that breaks out all the I/O on the SoC and allows you to access a lot of the power of the SoC itself. But one of the things that we want to point out is that Edison's not just a module. It's actually an ecosystem of product. It's the hardware, it is software, it is an ecosystem of expansion boards, and it's also cloud connectivity. The other thing that we wanted to do is put a very, very robust community support mechanism around it, because it's the maker community and the Intel engineers working together that actually create a phenomenal support mechanism. So about these expansion boards, one of the things that we did is we created a couple of expansion boards right out of the bat so that people could be productive right away. We created an Arduino expansion board, carrier was what we call it, and then also a breakout board that really just breaks out the 1.8 volt I/O on the SoC directly. But in addition to that, we also reached out to several key technology partners in robotics and then also in the maker space to create some expansion boards for Edison and be able to break out the fairly dense 70-pin Hirose connector that's on the platform itself. But we didn't stop there. We also went to a series of third parties that have the ability to create custom product for the end customer. A lot of companies don't necessarily have the ability to complete the product themselves, so we wanted to make sure we finished out that ecosystem for you too. So this is what our expansion board platform looks like directly from Intel. You can buy these today. The Arduino board on the left side there, and the Edison Breakout board on the right-hand side there. The Edison Breakout board, of course, is just a little bit bigger than Edison itself, and it gives you direct access to the 1.8 volt I/O. But again, we didn't stop there. We talked to the SparkFun team and several others across the planet, and we came up with a set of expansion board options that allow you to break out different aspects of I/O on the Edison board, allow you to do lots of experimentation very easily with these connected options. On top of the expansion board system and the middleware that we've included on the platform for the Iot Dev Kit, you'll see this on our maker.intel.com/Edison website. You'll also be able to add middleware to your application environment to allow you to do instant cloud connectivity. And on top of that, we also put a cloud analytics platform that allow you to play for free for non-commercial use on all the products that you want, including non-Intel products. And back over to Ed.
Yeah, so as we were getting the product ready for launch, we wanted to eat our own dog food and really make sure that the platform was rock solid. We have a really strong internal maker community at Intel, about 1,500 makers, and we reached out to those guys and we recruited about 70 of them that created 40 different projects across 10 different countries. And we created an environment very similar to an entrepreneur would have. So they got the platform 7 weeks before we brought the product to launch. We gave them a $1,000 budget, so very similar sort of financial constraints. And we just said, go make something that justifies having an Intel Edison inside of it. And we also, to Jim's point, we wanted them to go off and test this theory that we had on how easy and cheap it was to create your own expansion boards. And a lot of those teams did that. We also worked with a number of external development partners, and I thought I'd show you some of the examples that came up. So the first one is Shoebomb. So Shoebomb is a 12-year-old who about a year and a half ago, and this is a great sort of maker turning to pro maker story, as a 12-year-old thought that it was completely unfair for blind people to have to pay $2,000 for a Braille printer, whereas people with sight pay about $200. And so what Shoebomb did was he took a Lego Mindstorms and hacked together a Braille printer. And once he figured that out around sort of in the spring time frame, his dad works for Intel and contacted me at the beginning of the internal trial and sort of told me Shoebomb's story and wanted to be part of the trial. And we thought, well, let's see what happens. Let's give this to a 12-year-old and find out how easy it is to make this. And so what he did over his summer break, and I can tell you my kids didn't do anything like this over the summer break, he took an HP printer, took a 3D printer, and made a Braille printer head, and then used Intel Edison to power the whole thing. And because Intel Edison is connected to the web, he really thought through the types of use cases that we today get to experience and what would be helpful for a blind person. So he looked at, today we wake up in the morning, we look at our phone or the newspaper or whatnot to look at what's going on in the news. And so what he did was he had Intel Edison automatically go out to the CNN and print the headlines from a Braille printer. This was something that was shown at our developer conference about 3 weeks ago, and now he's actually turning this into a business. So a great story of somebody that went sort of maker all the way through to creating an actual product. These guys, as was shared earlier, from 3D Robotics, these guys are a quadcopter company, and they used Intel Edison to enable Follow Me, and not follow me through GPS, which is how a lot of these things work today, but follow me through sight, through using OpenCV, through a GoPro camera, and I'll show you a video of this in just a second. We also wanted to look at sort of the fashion side of this. So Intel's really big into wearables right now, and we wanted to look at what Intel Edison could do to sort of to power sort of a piece of clothing. And so we engaged a fashion designer, Anouk Wimprecht from the Netherlands, and she built a body area network. So this is a dress that uses EEG, EKG, and proximity. And if somebody was getting close to the wearer of the dress and the wearer was nervous about that person being there, these bulbs that you can see in the middle, 120-watt bulbs would get really, really bright and sort of flash in sort of a back-off kind of way. But if the person was sort of welcomed and it was okay to come in, they would sort of pulse in a nice, in a nice welcoming way. You can also see in the middle there, right here, there's a camera. So while all this was going on, Intel Edison was streaming the video back to the booth, and then you could see the EEG and EKG information as an overlay. So not something that would ever be productized, but I think just an idea of this really small and really powerful type of processor enabling sort of a whole new set of experiences. This one you can actually see in our booth. This is a hexapod, 3D printed hexapod powered on Intel Edison that does some sort of fun dances, so you should come and take a look at that at the booth. These guys built a farming robot. So basically it drives around the field and does soil tests and whatnot. And this is actually, a couple companies have expressed interest in testing this out in some farming spaces. And this is a great story. So these guys from Mexico wanted to create a smart construction helmet. And so they started, as you can see with the picture in the middle of the construction helmet, they started with the Arduino expansion board, figured out what they were doing. And sorry, the use case is if somebody gets sort of hit over the head or they fall or they're around a sort of a bad gas type of environment, that it would send a message out to a central office that the construction worker was in trouble. So these guys, in that 7-week period, took the Arduino expansion board, prototyped on that, figured out what they wanted to do, and then went off and had a really, really small, and you can see it in the gentleman in the black shirt in his hand, an expansion board literally the size of the Edison, and had that board made and got all that done in 7 weeks. They literally picked up the Edison from the larger board, plopped it on the next, and they had a prototype ready to go. This, as a result, and this was not intended at all, but again, a number of customers have actually expressed interest in productizing this. So let me show you a couple of videos that we shot.
What we built here,
I think we need sound.
Source humanoid robotics platform powered by the Intel Edison. What's great about the 21st Century Robot project is these robots are essentially talking Internet of Things. And so they're always connected to the Internet. They have all of the information that's available to that from...
Sorry, yeah, if we could rewind that a bit.
Headlines to being able to Google. What we built here...
So you never showed them here. Do you want to show them?
Humanoid robotic platform powered by the Intel Edison. What's
So
great
while
about
we're waiting to come up, this is relative size of Edison. It's about a little bit bigger than a postage stamp, that you see. Double-sided board. And one of the things that we've done for you is taken away a lot of the complexity associated with making a module like this.
And so one of the things with humanoid robots, and especially cute humanoid robots, is you end up eliminating that fear. What we've built here is an open source humanoid robotic platform powered by the Intel Edison. What's great about the 21st Century Robot project is these robots are essentially walking, talking Internet of Things. And so they're always connected to the Internet. They have all of the information that's available to that, from weather updates to news headlines to being able to Google things. Humans tend to be a bit scared of robots at times, and so one of the things with humanoid robots, and especially cute humanoid robots, is you end up eliminating that fear aspect because people think it's awesome, people think it's cute, and they want to play with it.
We built a smart helmet that increases the safety of the wearer by contacting emergency services when a crash has been detected. One of the next things we'd like to do is add a cellular modem to the helmet so that, for example, children who don't have a cell phone, their helmet will still be able to make an emergency call in the situation that they get in a crash. With lots of smart helmets out there on the road, we can aggregate a lot of important data, like particularly dangerous intersections, and we can make changes that increase the safety of riders everywhere.
The explosion of the rocket going up, it is something truly memorable. Particularly having your own experiment inside it as a payload.
We put this sensor on the rocket, and there's a company that takes it out to the Nevada desert and it launches it up to about 15,000 feet. It streams all the real-time sensor data. There's altitude, temperature, G-force, and several other sensors. And the students can watch it all live from their classroom through the cloud website.
Yeah.
Visual Follow Me, it's a prototype we built on top of a Intel Edison board. It's running image processing on it, and it's made so that a drone can follow you around doing any sports activities or being outside.
It was very exciting seeing the footage and that it could keep the user in the frame even if nobody was piloting the drone.